before we proceed further, let us look at characteristics of mixed strategy Nash equilibrium. First of all, definition of mixed strategy Nash equilibrium, that each player is playing the best response of given what others are playing. Each player is playing, that's important. The only difference that we have now, that we allow players to have mixed strategy, and so definition gets extended exactly in same manner, and here we have that definition. Only one thing worth noting is that typically what we say when we talk about pure strategy, we say that AI star should be doing at least as well as any other pure strategy, and this is true for all I. But when we are talking about mixed strategy, we are not saying that alpha I star should be doing as well as any other pure strategies, not necessarily mixed strategy. And you can think of the reason this is mixed strategy, but this is pure, this is mixed. What is happening? Remember that fundamental of all mixed strategy is made of pure strategies. So if alpha I is doing, this is true for all AI dash belonging to AI. If this mixed strategy is doing better than all pure strategies individually, or at least as good as all pure strategies, then if we take any convex combination of these pure strategies, alpha star would be doing at better or at least as good as any convex combination of those strategies. And that is the reason here the deviation, in deviation we write only pure strategies. That's what you should keep in mind. What are the characteristics? Two things that you should pay attention to. One, that if player I is mixing, let us say he has three strategies, the strategies are X, Y and Z, and in Nash equilibrium he is mixing between X and Y and he is not using Z. So then two things must be true, that his, given what other players are doing, let us say that other players are playing alpha star I, and then given what other players are doing, X is one of the best responses and Y is another best response, and Z could be best response or Z could not be the best response. When X and Y both are best response, what does it mean? That payoff from X given others are playing is equal to payoff from Y. So if X and Y both are being mixed, then payoff from X and payoff from Y would be the same given what others are doing. Second, that the strategy or action that is not getting used cannot be giving more than the strategy that is being used in mixing of those strategies. So it is not possible that the payoff to I from Z happens to be greater than X or Y. The reason is very simple. Then Z would be the best response and it would not make any sense for player I to mix using X and Y. He should be using Z. So it is very, very clear that this has to be greater than. So these two things we have to keep in mind, and these two things will help us obtain Nash equilibrium in mixed strategy. Let me repeat once again, the strategies, the pure strategies which have non-zero weight probability weight, if they are being used in the Nash equilibrium mixed strategy, then they must be among the best responses, and they all would be giving exactly the same payoff, because if one is giving more than the other, then what's the point of using the other? You should be using the only one which is giving you the most. So if X and Y both are being used against alpha minus I star, they both should be giving you the same payoff, and Z, which is not being used, cannot give you more than X or Y against alpha minus I star. So that's what one has to keep in mind. Next thing, before we move further, we talk about Nash theorem without proving anything. Nash theorem says that every strategic game in which players are having finite number of strategies or finite number of action has a mixed strategy Nash equilibrium. Of course, when we say here mixed strategy Nash equilibrium, we also allow for that pure strategy Nash equilibrium as degenerate cases of mixed strategy Nash equilibrium, and this is also called existence theorem. Okay, there are two important things that we should note, that it is reassuring that as long as you have a finite game and if you allow for mixed strategy, you are definitely going to have a mixed strategy Nash equilibrium. So Nash equilibrium exists, but it doesn't guarantee you that we will be able to find such equilibrium. In many complicated games, we are not able to find Nash equilibrium yet. Second thing, this is even more, this makes it even more broader, that finiteness is a sufficient criteria, it is not a necessary criteria. So even if players have infinite strategies, even then we can get a Nash equilibrium in those games. Okay, so these are the basic characteristics of mixed strategy Nash equilibrium. Existence theorem is because of John Nash. He proved it using a fixed point, Kakutani's fixed point theorem. We will not become that mathematical in this course, and therefore we are not attempting to even prove the existence of Nash equilibrium.